Hola, Geometry. Bienvenidos. We are going to look at Chapter 2, Lesson 6, and I have to say there is a slew of postulates and theorems in here. So I hope you're writing all these down and keep track of them because there's a lot of them. Just like last section, we talked about proving segment relationships. Now we're going to talk about angle relationships. And almost like the last section also, they start with such a simple postulate, it's hardly worth mentioning. This section does too. It basically just says if you have a protractor, you can put different numbers on that protractor and they stand for different angles. Okay? That's called the protractor postulate. One that's a little more important is the angle addition postulate. And it just says that if you have an angle, they use, they use A, and then they put B at the vertex, D, and C. So they're basically saying that if this is in the middle of these two in an angle pair, then the measure of this angle plus the measure of that one equals the measure of the whole thing. I think that makes perfect sense. Angle addition postulate. If you turn the page with me, they're going to give you a couple of theorems. 2-3 and 2-4. One is called the supplement theorem, and one is called the complement theorem. The supplement theorem just says that if you have a line and you've got two adjacent angles on that line that form what are called a linear pair, then the measures of those two things add up to 180 degrees. I bet you can guess what the complement theorem is. It just says that if you have two angles that make up a right angle, then the measure of that angle plus the measure of that angle equals 90 degrees. Continuing on, there are a couple different theorems about angle congruence. Just like with segments, they talk about angles being congruent, angle congruence being reflexive, being symmetric, and being transitive. That's all on the top of page 161. That should be just like segments that we talked about. Theorems 2.6 and 2.7 are useful. Those are the congruent supplements theorem and the congruent complements theorem. If I have an angle, let's do it that way. Just pretend these are two lines. It basically says that if we look at this angle here, if this forms a linear pair and this forms a linear pair, let's call this angle B, A, and C. If these two angles here are supplementary to the same exact angle, then it means these two are equal. Same thing goes for complements. If two things are complementary to the same angle, so you have a right triangle, boom, and let's say that you have a right triangle, so you have a right triangle here and you have a right triangle here. Does that make sense? We'll call this B, A, and C. So if A and B form a right triangle and B and C form a right triangle, then since they're complementary to the same angle, then C and A are equal. That's theorem 2.7. You can use that for a proof. Let's just do guided practice number 3, and it looks a lot like the drawing that I just did. Guided practice number 3 has a drawing like this. I'll try to do it very quickly. And they call this A, D, D, E, there's a point there, point there, point there, C, and this is B. So what they tell you is that this is a right angle and this is a right angle. Okay, so what we're supposed to prove is that angle ABD, this angle here, angle ABD, is equal to EBC. So if we set that up for a two-column proof real quick, our first statement is that angle ABE is congruent to angle DBC. And how we know that is that's given. Then you're going to say that angle ABD and angle DBE, I can't write all this here, are a complementary pair. I hope you can see that. And the reason for that is that's just the definition of a complementary pair. If two things form a right triangle, that's a complementary pair. You can do the exact same thing with angle EBC and angle DBE. Same thing and same reasoning. So now you see that we have two things that are a complementary pair with the same angle. Just focus on this angle right here. This is a complementary pair with it. This is a complementary pair with it. So that proves that this is equal to that. So angle ABD is congruent to angle EBC. And we know that by the congruent complements theorem. Okay, a little messy, but hope you get the idea. If we keep continuing on, they just keep coming with the theorems. Look at the bottom of page 162. There's a very useful theorem that talk about what vertical angles. Vertical angles, if you remember, are when two lines cross. That makes a vertical angle with that, or that with that. And what theorem 2.8 says is that vertical angles are equal. Then at the bottom of page 163, they give you 5 other ones. These are all about right angles. 2.9, perpendicular lines intersect to form 4 right angles. Boom. Oops, I guess I should draw that. So perpendicular lines make 4 angles. All right angles are congruent. That's the next one. If they're all 90 degrees, that doesn't seem like that hard of a theorem. Theorem. 2.11, perpendicular lines form congruent adjacent angles. 2.12, if two angles are congruent and supplementary, then each angle is a right angle. Congruent and supplementary, or you could look this way, or look this way. These are all going to be 90 degrees. And lastly, if two congruent angles form a linear pair, then they're right angles. All right. I think that is all for this chapter, or this section of the of chapter 2. I know that's a lot. You're going to write these things down, keep track of them, because we're going to use them in different proofs and different arguments as we go along. Okay.